Welcome back, Patriots. Let's move on to Lesson 2, Solving Systems Using Substitution. And just a brief little recap from last class period. System of equations is when I have multiple variables, and in order to solve for those, I'm going to use multiple equations. Look sort of down here at examples 1 and 2. We've got two equations. We've got two variables, in this case both y and x, and they're grouped together using this little bitty brace. That's how we show that they are a system that should be solved together. Now, when I say solve by substitution, this is our first algebraic method, which basically means we're going to be doing it using pencil and paper and not a graph or a table. And we're going to be using the concept of substitution quite a bit. Now, before we get into that, let's talk about what substitution actually is. Now, when we had an equation like 2x is equal to 8, and we got down to the end and we found that x equals 4, we learned that we could check this by substituting. Now, when I say substituting, I mean I would literally replace the variable with a set of parentheses and then take this equation or this value and substitute it in there. Replace the x with the number. So plug in the 4, and then I could verify that I had x equals 8. I'm sorry, 8 equals 8, and the equation is true. That's the substitution step. Now, we're going to be doing the exact same concept, not once, but twice in each of these problems. Okay? So here's our steps, and like I said, as always, these make more sense as we go through, or as we actually do them. So number 1 is going to be isolate. And remember, the word isolate means get something by itself. One variable in one equation. Now, I am going to mark that with a star, and you'll understand why that's a star when we go through. That is a very, very important thing that we're going to be using twice. Okay? Now, step 2, we are going to substitute that equation, star, into the other equation. Okay, step 3, we're now going to solve that should be EQU, solve the equation from step 2. Okay, now when we're done with that, we're going to end up with something that looks like x equals or y equals, one of those two. Okay, now we're going to substitute back into that star equation. And then we're going to do step 5, which is solve again. I know that doesn't make much sense right now, but it will as we go through it. Okay, so step 1. We'll look at number 1, step 1. Isolate one variable in one equation. Now, in this particular system, I've already got y equals on both of them. So the y has been isolated on both. Now, in that particular case, when y is isolated, or one variable is isolated on both, I'm going to choose the simpler one as my star. So up here, y equals -8 is much simpler than 2x minus 12, so I'm going to choose that one as star. Okay, step 2. Substitute star into the other equation. So the other equation is the bottom one. Y equals 2 times, 2x minus 12. Now, in this equation up here, I see y equals. So I'm going to go to the other equation and remove the y and replace the y with a set of parentheses. Now I'm going to substitute in whatever this is equal to. So I'm going to put it there, -8. Okay, that was step 2. Now in this particular case, those parentheses didn't help me out at all. In other cases, they will, but I'm going to do that step every time just to be consistent. Okay, step 3, solve this equation. So let's go ahead and solve that. Let's see, my first solving step is going to be, I want to get x by itself. So I'm going to add 12 into both sides. So that gives me -8 plus 12 is 4 equals 2x. My next thing is going to be divide by 2. And that is going to leave me with x equals 2. And yes, I flipped that around so I could have x equals. Okay, that was step 3. Now, step 4 is substitute back into the star equation. Now, my star equation up here, well, actually, this doesn't need to be done because it just already says y equals -8, but there'll be a time where that actually matters. So for now, once we've got x equals a number and y equals a number, then I can go ahead and write my answer. My answer is, well, there's 2 ways you can write it. I could write it as x equals 2, y equals -8. Or I could write as a coordinate pair 2, -8. Both of those give the exact same information. Okay, let's jump on this again. We've got y equals 6x and y equals 5x plus 7. Okay, again, we've isolated the variable on both. It's already isolated for us. So we're going to pick whichever one is simpler. And as I look at those, I think that 6x is simpler than 5x plus 7. Okay, step 2, substitute into the other equation. So that's my bottom equation. I'm going to replace the y with a set of parentheses equals 5x plus 7. And I'm going to take this 6x and substitute it in. So now I've got 6x equals 5x plus 7. Now we're going to have to pull out those solving steps from semester 1. When I got the variable on both sides, my first step is going to be get the variables all on one side. So now I've got 6x minus 5x is x equals, those cancel out, leaves me with 7. Okay, so now I've solved. I've got x equals 7. Step 4 says substitute back into star. Now, that's where this comes in right here. I've got y equals 6 and then parentheses. I'm going to take this x equals 7 and plug it in where that x was, and that's where my 7 goes there. Now, y equals 6. Oh, I'm sorry. 6 times 7 is 42. So again, 2 ways of writing it. I could write, again, x equals 7, y equals 42, or I could write it as the coordinate pair 7, 42. Either one is acceptable. All right. Let's jump down on number 3. I'm going to look, do I have a variable isolated? Now, this is going to be a little bit more interesting because I don't have y equals on both of them. So on this one, I do see that I've got y equals 2x minus 1. So that is going to be my star equation. I'm going to substitute into the other equation. So my other equation here is the top one, x plus 2. Now, I have y equals, so this y I'm going to replace with a very large set of parentheses, and you'll see why that gap is there in just a second, okay? So we're going to take all of this and substitute it into the y, okay? So that's why that set of parentheses needed to be so large. I'm replacing this y with 2x minus 1, okay? Now we're going to do our solving steps. So looks like I'm going to have to distribute this 2, which is going to give me x plus 2 times 2x is 4x. 2 times -1 is -2 equals 8. Now let's go ahead and combine our like terms. X plus 4x is 5x minus 2 equals 8. Let's add 2 on both sides. That's going to give me 5x is equal to 10. And now we're going to divide by 5 on both sides. Gives me x equals 2. Okay, that's one part of my solution. Now we're going to substitute back into the star equation, which is right here. I've got y equals 2. I'm going to replace the x with a set of parentheses. And now this value, the 2, is substituted in for where the x was. So that's going to leave me with y equals 2 times 4. 2 times 2 is 4 minus 1. So y equals 3. So again, x equals 2, y equals 3, or I could write it as the equation, or the point 2, 3. All right, number 4. As I'm looking at this problem, I can see that I don't have a variable isolated. I don't show x equals or y equals on this particular problem. So what I'm going to have to do is figure out which of these is going to be the easiest one to isolate. I've actually got to perform step 1 on this one, which I haven't had to do yet. So I see that this y right here does not have a coefficient. That looks to me like that's going to be the easiest one to isolate. Now, the way I'm going to do that is by adding 2x to both sides, and that's going to leave me with y equals 2x. Okay, now that y is isolated, which means that is my star equation. Okay, so I'm going to substitute that into the other equation. So I'm going to jump up here with my 6x plus 7y equals 20. So 6x plus 7. Now, instead of the y, I'm going to write parentheses. And when you write those parentheses, leave enough room for whatever this is. Okay, now that 2x is going to be substituted in for y. And now we're going to do our solving steps. So 6x plus 7 times 2 is 14. X equals 20. Let's combine our like terms. 6x plus 14x is 20x equals 20. And now divide by 20, and that's going to give me x equals 1. Okay, next step is to substitute that back into the star equation. So I'm going to jump back over here in my star equation. Y equals 2, replace the x with parentheses, and then x equals 1, so I'm going to plug that in right there, which gives me y is equal to 2. So again, x equals 1, y equals 2, or I could write the solution as 1, 2. All right, number 5. Again, I don't have a variable isolated, but I do see this y on top does not have a coefficient. So if I do y minus 8 equals 3x, what could I do to get y by itself? Well, if I added 8 on both sides, that would give me y is equal to 3x plus 8. Okay, I've got y by itself, which means that is now my star equation. We're going to substitute that into the other equation. So this came from the top one. So we're going to take the bottom equation now. 5x plus 2. Replace the y with parentheses and leave yourself enough room to fit that entire equation in there. And so I'm going to replace the y with 3x plus 8. Now our solving steps. 5x. Now we're going to distribute the 2. So that's going to give me plus 2 times 3x is 6x. 2 times 8 is 16 equals 5. Now let's combine our like terms. We got 5x and 6x makes 11x plus 16 equals 5. Now let's subtract 16 on both sides. Leaves me with (11x) is equal to 5 minus 16 is negative 11. Divide by 11 gives me x equals negative 1. Okay, so now I'm going to take this and plug it back into the star equation. Y equals 3. The x gets replaced with a parenthesis. And then inside the parenthesis, I'm going to put in my x value, which is negative 1. So that gives me y equals negative 3 times negative 1 is negative 3, plus 8. And negative 3 plus 8 is 5. So my answer is y equals negative 1, 5, which I'm going to write as my set of parentheses, or my coordinate pair, negative 1, 5. Okay, number 6. This one is a very, very weirdly worded problem, and quite frankly, the reason why we're doing this is because there have been several years that a problem exactly like this has shown up on the STAR exam. So I want to make sure that you guys are familiar with it before you walk into that test. So, find the value of x if x comma 3 is the solution to this equation. Now, realize what this is just an x, y coordinate pair. So all that this is telling you is that y equals 3. So we're going to go ahead and plug that in, and we're going to do 3x minus 4. We're going to replace the y with a set of parentheses and substitute in that 3. So now we're just going to simplify down. 3x, I'm going to draw my line for my equal mark. Now, negative 4 times 3 is negative 12 equals negative 6. We're going to add 12 to both sides, gives me 3x equals negative 6 plus 12 is 6. And then divide both sides by 3, gives me x is equal to 2. So actually you got to be careful because it says find the solution of x. And there's different ways of writing this. On a STAR exam, realize it's going to be multiple choice. So if it gave you something like 2, 3, that would be an answer. Or if it was just x equals, you would do x equals 2. So just whatever the multiple choice gives you on that type of problem. Okay, number 7. We're going to write and solve a system of equations for each. Okay, Mario went to the movies with their friends and spent $36 on candy. Okay, that sounds like a total value to me, but we'll see. Chocolate bars were $2 and bags of sour candy were $3. Okay, so each of those, chocolate bars were $2 and candy bars are $3. That sounds like a rate to me. So if I was to write that out, I would end up getting 2b for bars, 2 times bars, plus 3s, so 3 for sour candies, equals 36. The number of chocolate bars that she bought was 2 less than the number of bags of sour candy. Okay, so 2 less than. Oh, now remember that less than is one of our switch order phrases. So let's go ahead and write this in there. Number of chocolate bars, that's B. Number of chocolate bars that she bought is one of our equals. Now, less than means we're going to have subtraction, but it's 2 less than, so the 2 is going to go on the end because it's the switch order. The number of bags of sour candy with his S. Okay, how many of each type of candy did she buy? Whew, that was not fun. That's going all the way back to Unit 1 for translating verbal expressions into equations. Okay, so now we're going to look at our substitution. I can see that I've already got B equals, so that's done. So this is my STAR equation. So we're going to jump over to this one. 2, now instead of B, I'm going to write my parentheses, plus 3s equals 36. And I'm going to substitute in s minus 2 for b, because this got put in right where the b was. Okay, now let's take care of our distribution step. 2 times s is 2s. 2 times negative 2 is negative 4. Plus 3s equals 36. Okay, now let's combine our like terms. We've got 2s and 3s makes 5s minus 4 equals 36. Now let's add 4 on both sides. And so that's 5s is equal to 40. Oh, I said s and wrote x. Now, I'm out of room here, so I'm going to jump up to the top, but divide both sides by 5, and we get s is equal to 8. Okay, so we got 8 bags of sour candy. Now, we're going to jump back over to the STAR equation. B is equal to, we're going to substitute in, so the s we're going to replace with parentheses, And then we're going to plug in the 8. So B equals 8 minus 2 is 6. So B equals 6. So it looks like I bought 8 bags of sour candies and 6 chocolate bars. Okay. Rosalind and Liam own a clothing store and just put in an order for shirts and jackets. Okay, so it looks like we got shirts and jackets. I'm going to be using S and J. The number of shirts ordered was, okay, S is shirts, was is equals 5 times, wait a minute, we jumped to sleeping bags there. You know what, I bet this problem was modified off of another problem. Let's get rid of that sleeping bag right there. Let's just pretend that's not there at all. White that out for you guys, and we're going to say jackets. Okay. Let's go back to that. Number of shirts ordered, S, was equals 5 times the number of jackets. So that's just 5 times J. Okay. The shirt cost $4 each, so that's 4S. And the jackets cost $15 each, so plus 15J. The total cost of shirts and jackets was $595. Okay, so we're going to solve this system. And it looks like I've already got S equals, so that's my star equation. Now let's go ahead and substitute in 4. Instead of S, I'm putting parentheses, plus 15J equals 595. Now we're going to substitute that in, so the J or the S gets replaced with 5J. And now we're going to solve. 4 times 5J is 20J plus 15J equals 595. Now 20J plus 15J is 35J is equal to 595. And honestly, I don't know that one by heart. 595 divided by 35. Okay. Sorry, I should have said this earlier. We're dividing by 35. Then that gives me J is equal to 17. Okay, now we're going to substitute back into the star equation. S equals 5 times J, but J we're going to substitute for a 17. So now we're doing 17 times 5, which comes out to 85. So S equals 85. All right, so S equals 85, J equals 17. So we've ordered 85 shirts and 17 jackets. So that's all we got for you today. Good luck on the assignment. Feel free to reach out if you have any questions.